As Vasily said already, my name is Marta Habdas, and I work as a full-stack developer at Curiosum. By the way, we have our booth at the conference, so during breaks you can visit us, say hello, and also grab some goods. Coming back to the main point. As I work as a full-stack developer, but today I'm gonna talk about something quite different from web development, because I built a simple sound controller using Nerves. And as you can see in the title of my presentation, I wanted to test how concurrency and fault tolerance behave in this slightly less typical setting. So, yeah, because I think we often talk about these two in context of database bottlenecks or API throughput, but I wanted to check this in these noisy hardware environments. Yes. So, what was the origin of my idea? I wanted to build a DIY synthesizer, and firstly, I wanted to build it just with Arduino so Arduino with sensors to control audio in real time, and on the output I had pure data. But when I was working with it, like experimenting, prototyping it, I noticed that it failed often. And so, as people who probably had some experience with prototyping microcontrollers, you can know that many things can really go wrong, like wires can get disconnected easily, and even the whole board can crash, so our readings become unreliable, and we don't want it. So I thought that maybe it would be a good idea to use Elixir here, as it is known for systems that continue even though failures arise, and that can gracefully degrade. So I designed a physical architecture, as you can see on the diagram. It uses sensors distributed across 2 Arduino boards. Then the data from it goes to Raspberry Pi that serves as a brain of my system. And then it goes to the on the output to the pure data for sound generation and live view for visual monitoring our sensors. And here are features I wanted for the system to include. And I wanted it to be scalable. Like, I wanted to add more sensors, because now we have like 3 buttons that trigger musical notes. So it's not really an actual like musical instrument or sound controller, but some building block for it. But if I wanted to make it like actual instrument, I need more of them. I wanted it to be interchangeable, so I can swap output audio engines. And for me, the most important part here was the possibility to switch pure data for Super Collider, because I'm not very happy with pure data. And I think about including Super Collider instead of that. But because I use open sound control messages on the outputs, it's quite easy to do it, because it's like the output layer is really isolated from my Nerves layer, and also for this input Arduino one. So yeah, so it's also isolated, which also makes us like very easy to us to spot failures at the exact level and exact layer. Okay, so now I will present it in more detail. I have 2 Arduino boards, and the first of it I named Interactive, because it's responsible for user control, and it has 3 buttons, and they trigger musical notes like that. And also I have 2 potentiometers, and the first one is responsible for release time. As you can hear now, the sound is quite long. But now it's shorter. Now it's like very short. And also I have a filter cutoff, so I can cut off higher frequencies. I will show you how it modulates the sound. It's just like this, we can change it. Maybe it's not very like nice sound, but you get the idea. And okay. And also I have environmental board, which now I will plug it in. So you can see that it's also auto-detected, and I hope it will work and it will show us the additional effects. It's environmental because it responds to surroundings, and it has 2 photoresistors, one for node velocity and the second for LFO rate. I think the LFO rate should be the effect you will hear, like it will be most noticeable. Okay, it's like I should, if the release time will be longer, it will be. Okay, so like I'm quite surprised by how it sounds. Like it sounded a little bit better on my computer, but but you know, it's like this oscillating effect. And if I cover my photoresistor, it is slower. So it works like that. Like it also, you know, takes some adjustments to just make it sound nice, and it wasn't like my priority here, but I think it's also a very nice topic to maybe take care, you know, at the other moment. But yeah, but I think you get the idea. And I also have 3 temperature sensors, which added the reverb effect here. And I have 3 of them instead of 1, even though they handle only 1 parameter, because I use voting system here to handle failures. And I will tell you more about in the moment. Because, okay, live demo, it's like it was successful. And okay, we have also a dashboard, live view dashboard that shows all our sensors. Actually, the one is the temperature sensor is broken, and it's something I really like, because it wasn't broken like when I was, you know, testing it at home, but when I think during my travel, it broke. So we can see this failure case, like a real-world failure case. But you can see also values of our sensors here, and their status. And yeah, and it will be very helpful in handling failures, as I will show you in the moment. But I think, as you've already heard all the sounds, I can also just let's look under the hood on the software architecture. And actually, it's pretty classic Elixir. Like we have multiple gen servers here. They are managed by dynamic supervisor. And so like the main difference between something you would use in web development here is that instead of, for example, server processes, we have sensor processes here. So every sensor is isolated. So it's very good when the sensor process crashes, but it also has this isolated state, which I use in handling hardware failures. And also I have Arduino connection module, which receives data from Arduino with circuits UART library, because it's for now connected via USB. Maybe it will change, but for now it works like that. And also on the output I have audio engine that maps our values to open sound control messages with the use of OSCX library, and Phoenix Live View, as you've already seen. And here's the quick peek into the main handler from the sensor module, and it really does all the most important things for our sensor, because it fetches its value, it runs a series of checks to say if it's healthy. If it is, it sends it further to audio engine, it builds the state, and it's also repeated at the given interval, so it's a polling function. Okay, and so it's the time for the first test. And the failure case number 1 was about problem which really appeared for me like most often, because it's a problem of sensors being disconnected. Like, it's really very easy for these sensors to fall off or to cables to get disconnected. So I wanted a way to just see it like on our dashboard, to just have this easy way to handle it. But for example, if I had some audience that will hear all this sound, to hide it somehow. So I want to gracefully degrade, and in my case, it will be keeping just previous values. So I can, the sound will be the same, even though the sensor will fail. But I will see that it's broken. I can handle it, but the point is that I'm the only one who will notice it. And what I needed to do, I needed to ensure that I can say which data is wrong and which data is good, because in this case, Arduino will still send data, but I just use pull-down resistors. So if we don't have our sensor connected, the value will be zero. And in case of photoresistors, it actually solves my case, because in my setup, even in darkness, the value stayed above 10. So I just, to be safe, I assumed the threshold could be 5. And for potentiometer, I needed to add additional sensor, because in this case, we have 0 as a valid value, because we have range from 0. But I cut this range a bit with adding additional resistor. So it's a trade-off, because now our range is a little, tighter, but because we have this Elixir layer, we can map these values and handle it like we want. So yeah. So after all these hardware adjustments in code, it looks very easy. Like, we just compare values to our thresholds, and like with pattern matching is, I think, quite clean and easy to add additional sensors and different thresholds for some of them. And as I already said, in case of failure, we take the previous value here. Of course, we can do it differently. We can announce everyone that something broke by making sound, I don't know, really loud or something like that. But I wanted it this way. OK, so now the time for this live demo. We have our dashboard here. And I will take, for example, the potentiometer responsible for filter cutoff. But I remind you how the sound is now. It's like that. So I will take it out. And as you can see, on our dashboard, we have it marked as suspect. But if we replay the sound, it's still the same. So it's like how we wanted it to be. And yeah. And now I will take out the photoresistor. I think it can be a little hard because it's so small. And I'm kind of shaky right now. But it actually is a little bit slower because I covered it like before I was taking it out. But in the real world, it will fall off. So it won't happen like this. And wow, yeah. Yeah, that's, some magical things, I think, happen when you work with hardware. So, yes. OK. It's like putting it back is the, wow, it's still not, but with this dashboard, I can see if I put it, oh, no, still suspect, but it's because I just can't, am I doing it? OK. Wrong, it's just so small that if you like have to do such things and with audience, it's not very easy. Oh yeah, wow. So yeah, now it's everything. Okay, but yeah, but we can like assume that it worked all right because it's just like I wanted it to be. And okay, let's come back to the presentation and to the failure case number 2. And it's about the whole board crashing. And this time, the solution of the problem is even easier because this time we won't get any data at all. So we can just check the timeout, check if we have data or not. And as you can see, it's really simple. So no more talking. I will show you it. Yes. Okay, so let's play this sound. Okay, and now I will remove the environmental board. So we need to wait a little because we have like timeout of 5 seconds. But as you can see, it is visible that our board crashed. Like I crashed it by disconnecting it, and but the sound it's still the same. So the effect from environmental board stays because I just chose that way of handling it. And yes, and if I plug it back, it will, oh yes, yeah, it recovers, and we can see, for example, that it still works. Like if I cover photoresist, it's a little bit slower. Okay, so. That's how we got to the failure case number 3, and it's the most complicated one in terms of code, because now I wanted to solve the problem of sensor that is not disconnected but broken. So it can send data that is wrong, but we can't be sure that it will be 0, it can float, it can stay at some level, but one that we can easily discover. So I used the triple modular redundancy strategy here. So I used 3 sensors, and I just calculate the average of the one that are within our agreement threshold. So I choose agreement threshold I want, and it looks like this. I take pairs, like every pair from our 3 sensors, compare them, filter them to find which one are within agreement threshold. And when all of them are, I just calculate the average. If only one pair is valid, I calculate the average from this pair and mark the remaining one as outlier. And in not very rare edge case of 2 matching pairs, I take tightest part and reject the third. If any of the pair is matching, I just take the previous value and mark all of this as unresolved. Okay. So we have one outlier already, because I have this floating temperature sensors. It actually, as you have already seen, sometimes recovers because it sometimes, the value starts to float at the level which is within our agreement threshold. But even though it can seem like maybe something we don't want, because we can see our failure on the dashboard. In terms of our graceful degradation here, it's actually okay, because the value will be within our agreement threshold, and the sand shouldn't like change abruptly because the value will be similar to the two remaining ones. But yeah, but I will take and it's actually I just taken this outlier, but if I take out the second one, you'll see that it's unresolved. So that's the case when we will take the previous value here. I just don't, replace sand now because this reverb, like, it's very subtle, and also temperature sensors is like not very easy to showcase it because they take time to change like their temperature. And yes, and if I put it back, no, not this way. Okay. We can see it like that, and it won't be fixed completely. Well, for a little time because it just was in this agreement threshold for a moment. Okay, so that's it for our failure cases, our tests. I think we can say they passed, so I'm very happy that it worked. And also I was thinking about real-world applications here, because I think what I showed you is that it can be used as a development. This nerves layer can be used as a development, debugging, monitoring level in development process. So you can, actually, I myself use it for debugging all this when I had this mess after my travel, and and I needed to fix these cables. It was easier for me using this monitoring dashboard. So it's like a real world case, but it's for prototyping. And I was thinking about like maybe real world applications that are not only for development process. But I think we tend to think about embedded software in terms of the standalone objects or finished products, but that's not always the case. Like I attended multiple art exhibitions when they use such Arduinos with unsoldered breadboards, and also in this state of math. And I think actually it can be a good use case when someone would like to have this monitoring system and just know when something needs to be fixed and so on. So I think this quite niche field of arts may be a good use case here, but I was also thinking about maybe research education when you want to showcase something, but not necessarily to finish it, like you just don't want the product, you want something that is temporary. And also in cases then sensors exist in environment, which makes them very prone to failures, like in some cases of environmentals and smart cities in sensor networks, I think. Okay, here you have some links where you can find me, you can read the blog post or connect with me on LinkedIn, and thank you very much.